So this is just a sample problem, a problem that was given in one of my classes. This asked you to do more stuff with spherical coordinates. So basically finding the velocity and acceleration, which there's sort of a set of equations pertaining to each dimension, the r, theta, and the phi directions, which are the three spherical directions. But if you're just asking to convert from one coordinate system to another, you can just sort of focus in. Obviously the problem was asking about this area of this pickup truck, this arm. So if you were to, it's given in A, B, and C, but obviously as you can see with this reference coordinate system, A and C line up with the Y and X. And then in this case, using right-hand rule, everything's orthogonal to each other, so right angles. Z would obviously be going, in this case, use your thing, the z-axis would be going into the page, using this coordinate system. So if you were to try to convert this, you would sort of rewriting this here as a coordinate system. This A would be the x-axis. This C would be the y, and Z would obviously, you can't really show it, but it'd be going into the page, like straight down, because this is three-dimensional. But you can kind of tell that this is a spherical problem because you have this arm, you have a you have an angular velocity given as beta. So in this case, the r direction would be the sort of the direction of the arm. So basically converting from one coordinate system to another, especially with spherical or cylindrical coordinates, is basically just recognizing how things are moving, what logically can help you to solve the problem, because normally what you'll be doing is applying a coordinate system to get an answer, solve for the velocity or the acceleration or something. So this angle here is obviously the angle in this coordinate system. And then the theta direction is going to be orthogonal or perpendicular to the r. So that's making a right angle, 90 degrees. And then, never mind. This is the phi direction. And then theta will be going into the page. So, sort of the z direction. So we'll just write theta is into the page. And the way you just get that is basically by lining up, using this as a reference. You know that something has to be going into the page, same direction as beta. Something has to be going like that, so the phi direction has to be going out like that. And in this case, it will be making an angle of here. And if you want to convert from, for instance, you want to get it in terms of r and phi, basically what you will do is you will say that the x or the I, you'll set up a relationship, and same with the j. So in this case, it is the I is r times cosine of gamma, and then in terms of this, it would be minus phi times sine of gamma. Okay, and then in the j, or the y, j is the same as y, I is